zebra. So I'm using the same solution I had there, but on my input, and then we can try part 2. Alright, so I need the input. Paste that in here. Node.js. Let's hope it's also correct on my input. Alright, not a big surprise. And on to part 2. So we had briefly looked over part 2. Okay, so now everything has a time of a number of elves, and everything takes time. Don't need the terminal anymore. Alright, so what we were doing before is I want to call prerequisites task orders. Yep, that didn't work in line 34. Alright, so now we need a workers equal an array and const number of workers equals 2, const task equals 0, so this will later be 60 and this will later be 5. For I equals 0, I is less than the number of workers, I plus. Okay, so all these workers are not busy, and I think what I want to do is, as long as workers are not busy, I'm pushing a task on them, and then I'm counting down these tasks. So down here where I have the tasks, we have a potential next task. So here's a finished task that push L. So while workers index of 0, so as long as somebody has time, I take a potential next task. Okay, I guess I don't need this. But what I do need, if I remember correctly, we are looking for the total time. 15 seconds. How long will it take to complete all the steps? Yes. Okay. Equals 0, so y index not equals 0, want to do something like workers for I0 I plus workers dot length I plus plus if workers if we have a 0 worker, this one is free, so we're setting workers of I okay. We found a free worker, so this worker is working on task L, and here I want to use L dot char code at minus 64 plus task delay. So charcoal at A should be 65. Let's see. Add L equals A 65. So if I subtract 64, that's exactly the 1 second that I need. And then I'm adding a task delay because later there will be more. Okay, I'm adding this to the task. So now they're all starting a task. If I found one, I want to continue. Here. So I need to move this down. How does this look? So all the workers. Oops. While I have a free worker, I take the next task and then I assign it to that free worker and do something with the task. Oh, okay, I see. I need to change this because now there could be multiple tasks here that are being worked off at once. So I actually think this one should go back up. So while I have workers, I'm assigning them all the tasks. Next, I want to remove all these L's, and then I want to sort. Okay, so while I have workers and potential next task, length not equals 0. Starting add. I'm shifting stuff. Let task started. So I want these tasks starter push out. And I don't want to delete out, I want to delete all of them for let tasks in of tasks started and deleting task. Thanks for sticking with me through this. I will get a better microphone soon. Still trying to figure everything out. Okay, so I'm deleting all those that got started. This is all shifted one to the left. And I'm doing all of this while I have potential tasks. So when I do get to the end, oh, can they all start at the same time, or do I have to start over? Let me read that more carefully. So worker 1 works here, and yeah, they can start at the same time. Okay. So get to the end. So if I don't have any free workers, that's when I have to increase the total time. So if workers in x of 0, 0 if memory is free, then I want to use quickest task or shortest equal math.min of workers, and then I'm doing total time plus equals shortest, and then doing workers that map for every worker. I'm doing work time minus shortest. So this is sort of pretending that we just waited that amount of time. So instead of that time, we're doing workers that shortest. And I think at the end, I want to kind of do the same thing. So when we finish the task, That's something like all tasks started. So when all tasks are started, we want to, this is PS. Okay, when all tasks are started, then total time plus equals max of the workers. Constant that block total time. Okay, let's run this just with the test input. Okay, 21. What is expected here? Okay, it will take 15 seconds for 2 workers to complete these steps. So close but not close enough. CABFDE. CABDFE. So why is this different? No, we want CABFDE. Okay, so the order is wrong. Okay, we have a potential next talk. Then workers, if somebody is free, and we have a next talk. So here we're pushing L, and we set worker 1 to 1 second. And we're pushing L into task started. Okay, I think this is good. I need to finish tasks. Okay. And now we're removing L from all of those. Okay, we don't have another potential next task. So we're removing L from all of those. And find the next list of potential tasks. Okay, so I have more. None of them are started. Now there should be a second one. Oh, I'm starting too early here. Right. So we have potential tasks. And nobody's free, that's not the case. We have workers and we have potential tasks, so assign them that task. And now how long do we have to wait before we can remove all these other tasks? So this worker has 3. Okay, so if not, so we don't have any more tasks, so now we want total time plus equals basically you want to do this. For every worker, no. For every started task, we want okay. We have one potential task, so we're starting that task, and now we have no other potential tasks, so we have to wait for the first one to finish. So let min equals math.min of workers, and total time plus equals the minimum, and workers equals workers.map every worker time goes to worker minus that minimum. Okay, so we added the 3 seconds, and now the first task is done. This is one we started. Oh, this is tricky because I cannot remove all of them. I can only remove one, so I might have to work more with maps here. So task started is, I want to say, a new map, and the map is the task, so the letter and the worker index. So nobody's free, so we're subtracting time everywhere. Now one of them is free, so we take the potential next task and assign that to L. This is wrong. The next potential task should go in here. So somebody's free and we have a task. So we're finding the free worker and we take the next task. We set the worker to this task and we also say task started that set this index is doing. So this task is done with this worker. This is not quite right. We don't want to go here through the end. How do I find multiple workers? Multiple indices in an array. So I want workers that find index. What is that doing? No, not the first one. Index of also the first one. Find all occurrences in array. Okay, I'll find all indices. In a loop. I will prototype that. Reduce. That looks good, I think. Okay, so we want workers.reduce a function. Accumulator is the empty array element in the index. If the element is equal to 0, then we want to oops. That is not if this is equal to 0, then we want to push the index. And we want to return the array. Okay, so we found our little stuff at 0. Let free workers equal that. So while free workers the length and potential. So while somebody is free and while we have a potential task. No, we don't need to do this, we just do I of free workers. We know that they are free. So we take the next task, we assign that worker the time, and we now start it out for this worker. Okay, why free workers? Let's do this differently. Let I equals free workers the top. Let L set the worker. Okay. Yep. Okay, if we don't have any more free tasks, then we have to wait out the time of these workers. And once that time is over, now we can remove not just L, but all those that are finished. So let's do again the free workers. And then here for let task of where are we starting this task? I think this has to be outside. So some of them start a task, and now for all those that are free, let L equal task started get free worker. So this index, okay, the free workers are the indices. Yeah, for all the indices, get the free worker. And then we want to remove L. This is very wrong. This is outside of the function. Okay, let's see. Ooh, this is way too long. Okay. So when we have a potential next task, if nobody is free, then we have to wait the time that the shortest task is. So after this, at least somebody is free, obviously. So we take these free workers, and we're going through the free workers and the potential task, and then we're popping a free worker and a potential next task. Actually, I like shift better because I'm kind of coming from the left. And then workers of I is waiting these times, and then we're starting task for worker I is task L. If we're out of free tasks, if we're out of tasks, then we let all the workers work. Okay. So we don't have any potential tasks, so we need to wait. We don't have any more tasks, and somebody needs to finish. Okay. So a few of them might have finished now. And now for everybody who's free, we're getting the task that they just finished. And we're removing it from all the other prerequisites. Yep. I want to say only there's a loop missing here. While potential next tasks. This should not be over here. Okay, we don't need finish tasks anymore. Okay, let's look at this loop again. While we have a task, if nobody is free, then we wait until somebody is free. Then otherwise we know somebody is free, so as long as we have free workers on tasks, we add them to the workers. Now if we don't have any more tasks, we wait this long, then we look at all the free workers and let free worker. What's the problem if I don't delete these other tasks? Well, let's just see what happens. Around 15. Okay, that was way too fast. Bummer. Okay, we're doing this while potential next task at length. Okay, nobody is free. Let's start some printing. Console.log worker I worker. I started L taking workers of I seconds. Okay, worker 0 started C, taking 3 seconds. That sounds good. Now this list should be empty. So we're waiting 3 seconds. Okay, so now the free workers should be all of them. So both. Yeah, what is wrong here? Okay, one of them started, so now let's do console.log workers. 3, 0. Okay, now we waited 3 seconds. Oh, why is the minimum 0? Mastered men of workers. Ew, he stays 0. Okay, so we need mastered men of the free workers. So we have the free workers and they potentially. Oh, thanks for letting me know that you can't see all of my terminal. 1 second. Oh yeah, that is weird looking. Yep, okay, let me move this. Sorry about that, thanks for letting me know. Those are good numbers. Okay, so we only want the minimum over there. Free workers here. I feel we really should make a function for free workers. So now, yeah, thanks for noticing. It's Friday afternoon and this is not very easy. Okay, I want to subtract 3 and I'm ending up with 2. Okay, that didn't work out so well. Oh, because free workers is only my index. Yep. How do I get the minimum number that's not 0? Okay. I don't want the free workers here. I want the minimum of workers that filter where the worker returns the elements of an array that meet the condition. So I want all those that are not equal to 0. Now that should be 3. Yeah, so those are 3, and now I only want to subtract that from those that are bigger than 0. Okay, got the right minimum. Workers that map. I'm going to write this out, otherwise I can't do it. If W equals already 0, return W, else return that subtracted. Min typo. Okay, what am I even printing here? I'm printing the workers, and I'm waiting 3 seconds. Waiting 3 seconds. So now they're both free. So the free workers are at index 0 and 1. And then I'm taking the task that the free worker started, which was C. Okay. And then I have an undefined in here. That's probably not quite correct. So now I want to remove L from all the prerequisites. Yep, and at the end I'm adding the max. Okay, where's the next console log? What am I logging here? Workers, oops, workers after starting tasks, and then I'm logging, I get the minimum, I get the free workers. Where is this undefined coming from? Oh, maybe the next L is undefined. Yeah, I think that's my problem. So this is task that was just finished. And yeah, I think that's the problem. Yep, it's an unfinished task. So this is my L. So if not L, continue. I'm done with the free worker. I have an L. pushing more tasks. Okay, when did I lose the ability to fight these other tasks? So I have L. Task orders from the entries. And these are the prerequisites. And if I don't have prerequisites, I'm pushing more tasks. Okay. Have an L. Task that was just finished. I want to remove it. Console.log key and prerequisite. Okay. Let's do this. Okay, so for the task prerequisite delete task, if the size is equal to 0, then I want to push this. Console.log delete from task. Delete from task is 0C. Why is task 0, C? Oh, am I pushing the wrong thing? Oh yeah, task started, deleting not 0C index task. Okay, getting closer. Not quite the right number. Anybody have an idea what's wrong here? Oh, I guess we can look at this. Clean this up a little bit. This anymore. Okay, worker 0 started C, taking 3 seconds. Workers after starting task, 3 and 0. Then we finish C, and then Z started A, and 1 started F. Let's have a look at the sample solution. So after 3 seconds, A and F. A is taking 1 second, so we should see that then B is getting started. So workers after starting is 1 and 6 seconds, and then we finish A. Worker 0 started B, taking 2 seconds, so we're waiting 2 and 5 seconds, makes sense. D with 4. Okay, so let me print, let's have a look about the total sum. So when we start the total time, oh wait, is there a task missing? Oh yeah, they never finish E. call. Is that the missing 5 seconds? Oh yeah, E is... I guess E is just these 5 seconds. Wait, actually I'm looking back at the sample solution. So worker 1 is doing D. Oh, and only when D is finished can we start E. That's why worker 2 doesn't start off E. Is that right? Yeah, only when D is finished. Ooh, thanks so much for pointing out E. Okay, let's see where E has gone last. Okay. Where is E? So while we have the next task, now I need to look at this outpost. So task that was just finished is F, and E comes after F, right? No, E comes after D is finished. Worker 0 started D, and I guess we are now... F finished at 10. Okay, let's look at this sample documentation. So E should finish at 14. Why is there one extra step anyways? Okay, but if D finishes at 9 and my output is 10, then that's kind of what we want, because E is finishing at 14, and we need to have 15 as the right answer. So I think D is okay. Oh, but you're saying F is maybe not okay? So F should finish at 9. Where is F? No, I think F... Oh yeah, F took one too long. Bummer. Yeah, I'm not writing down that D is even finished, and I want to say F is actually at the wrong time, maybe, and E is missing. This is getting really messy. I wonder if I should refactor. So why do we not see? Let me add a debug statement for when something is finished. Yeah, total elf chaos. Done all by myself. Oh, hold on 1 second, I need to get a charger. Okay, back with battery power. Okay, without E10 is correct. Yeah, but the F, I think, is still wrong. Okay, maybe F is okay. So I think my problem is that I'm finishing this loop too early. Maybe. So if nobody is free, then we wait until somebody is free. Okay. So for F, we have somebody who is free, but we don't have a potential next task, which is this one here. We don't have a potential next task. In which case, we're waiting the time for A to finish. I think this is when A should be finishing. And now both of them are free. And for all the free workers, we just need to add ease duration. Not sure what you mean by that. Like, at the very end. What do you mean, just to cheat my way out of this? So if we look at the output again, it never says anything about starting E. Why not? Okay, but why is nobody even starting with E? So here's my potential next task. For all the free workers, I'm doing that, and I think it's okay to sort them one step below. Oh, maybe this is the wrong spot, because this is never called. I think I have too many function layers. Wait a second. What's happening here? Oh, here, next tasks. For some reason I have nothing left here. Next task is D. Yeah, so next task is D, and then worker 0 started D, taking 4 seconds. Workers after starting task 4 and 3 seconds. Let's see in the solution once again. When they start D, yeah, 4 and 3 seconds, so that looks right. It's probably a stupid plus or minus 1 error. And so they do D and then they finish F. Okay, I think we're close. So the second one just finished F, and the first one still has 1 second on D, but F cannot start anything new. So yeah, I think so. Hold on a second. So we just finished yeah, E is weird. It doesn't know that it could be finished. We just finished F, and we're removing F from everything, but E at this point is still depending on D. Okay, so we don't have any next tasks, but we are not done yet. Oh, I see. I think I understood. I'm finishing as soon as I have no potential next tasks. But really, if I don't have potential next tasks, I should be counting down the time until more dependencies resolve. So this should be if we don't have any next tasks and all workers are free. Does that make sense? Kind of makes sense to me. Sorry if this is confusing. So and reducing the workers. This is so happy. Dot length is equal to number of workers. So while we have a potential task, or while the workers are not quite ready. Oh my god, don't ever show this code to anybody. No, and it didn't even work. Oh, but we got further. We finished... Nope. We finished D, we finished F. Hold on 1 second. So we started D. We finished F. Let me copy paste code like I want. Sorry, okay. I know, I'm just like digging myself a deeper hole every time I'm trying to shortcut this by adding ugly code. Okay, D is next. The first one takes D, which takes 3 seconds, and then F is finished. And this looks weird that we're finishing F twice. But we don't have a next task. Okay, we're getting closer. So we don't have a next task, and the workers have 1 and 0 seconds left. And now we finally finished D, but after D we should pick up E instead of F. Okay, what happened? So one worker is still busy. One of them is free though. Someone is free. We don't have a task. We don't have a potential next task, so I think we're falling into this loop here, where I just fixed that. Okay, yeah, F just really wants to finish a few times. That should not happen. So we don't have a task. Okay, you're saying I think if you just move the declaration of free workers variable outside the loop, I don't need to reduce it twice, but it's changing all the time. Okay, yeah, let's clean this up a little bit because it's really not pretty. Free workers. Do I even have workers here? Yeah, I think so. Is all those. So really it should be the right number at this point. We really would need the 2 reduces. Okay, so I take the free workers, which in this case should just be the same as workers, but okay. No, it's actually pushing the indices. No, it's pushing the indices of all those that are free. So let's have a look at this F finishing twice. Tasks are just finished. So, oh, F is finishing twice because I'm not overriding it. What I really should be doing is delete it from that set. So task started. The worker is free. I should be doing task started dot delete. I want to delete that one. So this should take care of F not being deleted twice. Okay, no, it deleted everything. Never mind. Okay. I really wanted to get this done before dinner. Shoot. Okay, I'm deleting them here, and I think I also need to delete them here. Yeah, it requires especially a lot of logic if you don't write nice code and you just get a big chunk of spaghetti code and you copy and paste everything all over the place. Nope, that was still not it. A started. What is happening? Yeah, well-known facts. Facts I should know really well. Okay, this worker is working on this task. Why is it saying delete from task? D is 4.3 and okay, I think I broke even more because I don't see F being finished twice now. Oh, I don't see D finished anymore because I made that change up here. We had the free workers that length, and I'm supposed to update the free workers at the end, I guess. Let's go to the end of the for loop and update them once more, just to copy some more code. No. Task that was just finished is F. Where's the double F finishing? Or was it D that finished twice? Ooh, you have really smart tasks. I thought I could just work with these lists. Okay, tasks are just finished, so we finished F. And then we have a next task. Let's figure out where D gets stuck. So we finish F. Somebody is free. We have free workers, we don't have a potential next one. So then we go to potential next task. No more task, let's wait for a new one. No more task, let's wait for one to finish. Oh, next task. Okay. Yeah, I should have just thought this out better instead of working through it. Okay, so F finished. Then I don't have next tasks. Why? Ooh, nice. Good job. Yeah, I'm not making any board today. Not even sure if I can finish it before the next problem comes out. Okay. That was hard to read, P1. So this is 0, and my free workers should be 1. So I have the next task. I have no more next task. That's okay, and for some reason it now just finishes. So yay, debugging like a pro. Let's see if this is true or false. It is true. Why does it not start over? Okay. Like, I get so nervous, like pressured when I try to solve something for time, so I'm deliberately not starting them when they get out, but like in the middle of the day. Okay, so this is true. So we're starting the loop. If we don't find them, that's not where we go. And we're using the free workers again and again and again. Yeah, that sounds really stressful, Keith. How's your heart rate doing with it? Oh, when I first started giving talks, I was incredibly nervous. And I thought, as nervous as I was, that my heart rate would be out of, like, through the wall. And then I was actually wearing the little Fitbit heart rate monitor, and my heart rate actually went way down during giving talks. I thought that's like so weird. Okay, but still, that sounds like a stressful way to solve these problems. Okay. So we have free workers. We don't have a task. Why does it not get to this? Next task. It is true. Why this? So we should be starting here. Okay, you can tell I'm not super focused anymore. Did I have like, do I have a return in there or something? I don't get it. So I'm console logging this here at the very end. And it is true. So I thought I would jump back to this while loop and print held 1. Why is this not happening? Oh yeah, I watched a few Go solutions and I felt that pausing the input in Go and splitting up the strings is way harder than in JavaScript. And I don't know any C#, so. But the Go string tools don't work well. Okay, I think I need your help here. I'm at the end of this loop and I'm printing that condition. And it's true. And I jumped to the beginning of the loop, but apparently I'm like leaving the loop because for some reason it is wrong. Like I never get to print this debug statement. No. Copy and paste. See, I have one. I'm really confused why I'm not staying in this loop. If the condition is true and nothing else is changing, and I just copied and pasted that statement into console.log. Oh, I want to print those. This is really fun debugging here. Oh. Okay, so free worker length is 1. Then I go to the beginning of the loop, and before I can do anything, it's 2. Where's my second free worker coming from? Ooh, that sounds nice, visualizing it. Do I have more than one free worker variable because I tried to be smart and move it out? Oh, gee, okay. Whew. Okay. So we finished D. We don't have any more next tasks. Oh, we finished D. And then we finished F, but when we finished F, yeah, things are hanging in there with me. That's one of the silly mistakes that you don't make if you have a large monitor and if you write clean code with nice function names. Okay, so F finishes and then F finishes before D. Whereas for me, no, F finishes and then D finishes, and for some reason there are no next tasks even though D finishes. Also, I need to remove this. Okay, so D finishes. I know, especially when it's something silly as that, and you're like, it's 1 over here and 0 over there. Why would it change when nothing in between is changing? Okay. Okay, for some reason the mod thought your Ruby message contains profanity, but I think it's all good. Okay. D is finished, and then the next task is an empty list, which is set. So we just finished D. We finished D. Delete L and push that. Okay, so once we finish D, I want to see if L equals D, console.log the orders. There's only E. Ooh, why does E depend on B? That should have gone a long time ago, right? Didn't we do B like ages ago? I mean, B was done like all the way up here. Okay, so something's seriously wrong in how I delete stuff. Do you see that? I finished D, which is fairly down. I think it's the last one that we're finishing because we're not finishing E, and for some reason E still depends on B. Let's see if we can figure that out in this mess of a code. Okay, remove L from all of them. Okay, let's say if it's B, because somehow B gets stuck there. And then print this again. Okay, so... Oh, did we never finish B? A, F. Next task, BD. B takes 2 seconds. Next task, D. F just finished. A finished. D finished. I think B never finished. Ugh. Maybe I'm deleting the wrong thing. Is the delete supposed to be on task started? Is this continue right here? Let L is the pre-worker of these tasks. I think what I meant to say is if... No, that's the task for the free worker index. And I wanted to say if that's undefined, then continue with the loop. I don't want to break out, I want to continue. Okay, when is B finishing? B finishes before D starts and before F, but after A. Okay. Unfortunately, I have to go for dinner. I might try to finish this after dinner, but thank you for sticking with me and like working through this massive debugging challenge. Maybe when I come back, we should first refactor this and then keep working on it. All right, thank you.